decide to use the unit of those size divisions that we're going to use. We have already ordered our frame, so we're ready to go. So how do we do that? Well, so selection of the sample involves selecting a random number R. Probability of selection is how it's going to be. Well, I think I'll just this is all. So we pick a random number, R, and usually this is one thing, and it turns out the number that I actually chose, 18. Now what do we do? Well, what we're going to do is we're going to create a sequence of systematically ordered numbers. The way we're going to do that is we're going to take 18 to be the first entry in the sequence. And we're going to add 30 to the consecutive list for each additional entry in the list. So we'll have a sequence of 18, 28, 78, 108, 138, 168, 198, and 7, etc. And we have 34 numbers following this sequence order. Now, does everybody see the similarity? Systematic standard, we'll see that this step is where systematic reduction occurs. It's systematic because we pick the range to start, and then we apply a constant interval of 30 to produce 13. This is where systematic standard occurs in selection reduction. The point is, how are we to use this sequence of numbers, 18, 28, 78, 7? This is where we apply our PBS selection rule. PBS selection rule is a rule that we use to decide which of the random apply which issue will apply. The rule states, this is what we're going to do, we're going to select our one is the smallest unit value of the size that we have each of the issue. So let's go see that out. Here's the final list of the first 34 entries on frame. The first in the sequence was 18, right? So we say 18. What is the PSU lambda with the smallest cumulative greater than or equal to 18? Well, it's the second lambda. So we write 18 to tell us what entry in a sequence of systematic numbers caused us to select this one with 18. It's 1 to 2. The next entry in the sequence is 40. So we find the lambda with the smallest cumulative greater than or equal to 48. It happens to be the lambda with a cumulative of 48, the fifth one. Here's the second one. The third one, 78. What's the lambda with the smallest cumulative greater than or equal to 78? Turns out it's not this, it's not this one. It's the one with the cumulative of 86. You see, a very simple process. You can write a little simple algorithm to draw this sample. But we do that same thing. Every place you see one of these numbers in the right-hand column, you're looking at one of the 34 entries in the systematic sequence of numbers. And what you're seeing listed next to is the one that is chosen, the code number, following the formula. This is about, we just did this. So, we got 24, count you got all the numbers here in the right-hand column. You kind of find that everyone is really on the left hand of the but it won't hit you with this code. The hitch is when the size interval, 30, C5, with the full less I plus 30, T30. Now, if you stay in this column throughout the whole thing, we'll find there is no lambda on the front value of the beta state. On the other hand, the line is just going to be huge. Unless alpha, it was a star of 50. What we would find is that not only would we select that lambda once, but we can select it multiple times. Right? Because you're still applying the rule. The lambda with the smallest term greater than or equal to, but you're going to get multiple hits at the 3 consecutive numbers or 2 consecutive numbers once every 3 will be. So it is possible in this approach, if you have huge lambdas or huge PSUs relative to the size of others, it is possible to select PSU, very large PSUs multiple times. So with sort of have viewed that look at samples of counties in the United States, for example, and use this form of PPS-matic survey, what they found is that they will make multiple selections. They'll select Los Angeles twice, they'll select New York twice, and Miami twice, Philadelphia, and so forth. That's possible. So what do you do when you select plus or minus anytime. Well, whatever you're planning to do in the next stage, you have to repeat that many times. If you selected this Lambda 3 times, it will select 3 separate samples according to whatever you're planning to do in the stage. Okay, so once we have gotten to this at 5, we draw a line, and we are at finish of the first stage. The sixth stage, the sixth step, we're at the end of the 6 and 7, involves selection of the secondary stage, the second stage. Because what we do then is we take each of these landas that we selected here, this one, and this one, and this one, and this one, and we send a team of map experts, cartographers, to each of the landas, and we say, your job is to, in this case, map this landa and subdivide it into exactly 10 segments of approximately 40 houses. Good job. It took a while to do. But that was the approach that we took. So they would draw their map, form their segments, and at the conclusion of that, we would have exactly MOSI star segments formed in each of the BIOS. And then what we said in our final step is that we selected exactly one segment with equal probability, and we select all households within each selected segment. Notice that I've added that. You didn't copy it up there. Step 7 says, once you form the MOSI star segments within each selected lambda, you must select one at random and send inwards to, including the study, all households and all women of childbearing age in those households. So what would have happened is they would have, let's say, this is the one that was selected, number 3. The interviewing team would have gotten a map like this, an enlarged map, with the area, according to the tree area, and be told to interview all households that they find within Area 3. So the quality of the map was quite important. Now, the last thing we're going to do here is we're going to verify that we have probability selection of 1/30. Okay, I'm going to claim that the first stage probability of selection of selecting landas turns out to be equal to the size range of the household divided by the selection interval we're selecting. Because omega 0 is 30. Selecting a random number between 1 and 30. I'm going to help you to believe that one. So that's for here at the moment. So this is the probability of selecting landas. We selected one out of MOSI star segments and enumerated all of them, so the probability of selecting a household within any selected segment within a given lambda is 1 over MOSI star. So what happens is that the MOSI star is canceled, and what we're left with is 1 over pi sub O, which is, as we know, equal to 5 sub O. 1 over omega sub O is equal to 5 sub O. So what we did here, the trick and the strategic element of this design was listing and selecting landas in such a way that the first stage probability is MOSI star divided by omega O. Now I'm going to leave you with a challenge to think about this. We'll talk about this at the beginning of class on Monday. But in order to convince yourself that this, in fact, is the probability of selecting each lambda, what I want you to do is to ask yourself, when I selected my sample place, what I did is I constructed an array of systematically chosen numbers, starting with 18, 48, 78, and so forth, etc. Now, when instead of selecting 18, I could have selected 19, right? So then what would the array have been? It would have been 19, 49, 79, 109, etc. If the number I'd chosen was 1, it would be 1, 31, 61, 91, etc. So there are 30 possible samples of lawn text that you could choose by this approach, right? Does that make sense? Only 30 possible samples, given this ordering of the lawn text array. I want you to ask yourself, so we got a random number between 1 and 30, so we have 30 different outcomes to the source of randomization that chooses our lawn text. 30 possibilities. I want you to pick a lawn text. In fact, I'll pick one for you. I want you to think about this, and we're going to talk about this in today's class. Okay, this is right here. Number 26. That is the one we selected. Entry number 46 is always circled. I want you to verify that the probability of selecting that particular lawn text was 4 over 30. The way I want you to verify it is not to use some theoretical mumbo jumbo, but just to think logically. You've got a source of randomization. One source of randomization that selected this sample of launches. Where did it occur? It occurred when we picked the random start. That's the only place where randomization occurs in drawing the sample of 34 launches. How many possibilities to that source of randomization? 30. 1, 2, 3, 4, 5, 6, 7. So ask yourself, how many of those 30 possible random starts would have caused you to select this one? Now we know that 18 is, right? Because there it is. 318 was in our sequence, and 318, applying our BBS selection rule, caused us to select this one. But there are, you're gonna look for 3 others, random starts are, that would cause you to select this one. We'll talk about that in a minute. But the point here is the strategic elements of forming the frame. There's a strategic element of how you use PBS systematic sampling to manipulate the selection probability. The use of MOSI star rather than MOSI to draw the sample. All of those things together produce a sample that has some good properties, with stratification implicit, and a sample of households where all households have the same probability. This is to illustrate that, as I preach time and again, that designing a sample you don't do in a vacuum. It's something that has a thinking and strategic element to all of what you do. This will be one of the best things that you will learn about the sampling project. So on that note, also, please remember, if you haven't already gotten together with your group or exchanged emails or whatever, you guys need to come on Wednesday at a scheduled time. Chris will be sending out an email probably sometime later this week to tell you what time you come on Wednesday. So your group only needs to come for that time, or whatever the length of time is, 10 minutes, whatever. That's all we'll do that day. Just talk about the elements to set the background. Okay, see Monday we'll talk about the PBS selection.